When we have a many-to-many relationship, we have three tables. One of these tables is an associative table, and there are two relationships between these three tables. An example of this many-to-many relationship exists in the text database between three tables that are sale, line item, and item. Let's take a look at these tables. If I execute all of these three queries, we will get the three tables. The first is the table sale. In the sale table, we have sale number, sale date, and sale text. Each of these is a sale that has taken place in a store. The third query gives me the item table. The item table lists various items that are available in the store for sale, ranging from 1 to 20, with an item name, an item type, and an item color. The line item table is the associative table that brings these two tables together. A sale may have many items, and an item can be on many sales, and so we have the line item table. In the line item table, you will see two important columns: sale number and item number. Please note that sale number can show up multiple times in the line item table. Please also note that item number can show up multiple times in the line item table. And so there are one-to-many relationships between sale and line item and item and line item, capturing the many-to-many relationship between sale and item. If one wants to join these three tables, it's very straightforward. Select star from sale, start at one end, join the line item table on sale.sale number is equal to line item dot sale number. Sale.sale number is the primary key of sale. Sale number in line item is a foreign key. To this, we're going to have another join. We're going to join the item table on item.item number, which is the primary key in item, being equal to line item.item number, which is the foreign key in line item. If you run this query, you get the three tables together. You have the sale columns, you have the line item columns, and then you have the item columns. This is how one would join three tables that are part of a many-to-many relationship. One can be a little bit more specific and ask about picking specific columns from the tables. Let's say I would like the sale date and the sale number and the items on that sale. One can get that by writing and all of the joins stay the same. Now, if one does run this query, one might get a response saying that column sale number in the field list might be ambiguous, and that's because sale number is part of the primary key of sale, but it's also present in line item as a foreign key. So there are two columns called sale number in two different tables. We need to let MySQL know which column we are referring to. And we can do that by typing in sale.sale number. And I get the following result. And so I find the sale date, the sale number, and the item names or the items on that sale. This is how one might join three tables together. Another SQL clause that can be used as part of the select statement is the exists clause. An exists clause returns a true value if a query returns at least one row. Let's say I want to find out items that have been sold. Items or the item names of items that have been sold. So I could select item name from item. Now, if I want to know if an item has been sold, I can write a where clause. Now, how would I verify an item has been sold? Well, I would know an item has been sold if that item number exists in the line item table, right? If it exists in the line item table, that means it has to have been sold. If it doesn't exist in the line item table, it has not been sold. Because line item captures information about items and on which sales they've been on. And so I need to find item number some way in line item. So I can write select item name from item where exists. And then I would have a subquery. Now, this subquery is actually a correlated subquery because what we're going to do is we're going to select rows from the line item table where the line item table's item number is equal to the item table's item number. This subquery is going to get only those rows from line item where the item number that's present corresponds to the item number of the item name in the outer query. If I run this subquery, if I run this query, I will get 12 rows returned. That is, of all the 20 items, 12 items have in fact been sold. How do I know I have 20 items? One can go and simply run select star from item, and you will see that there are in fact 20 items. Now, the exists clause might seem like a roundabout way of getting item names from items where items have been sold. An easier way to actually look at the implementation of the exists clause is to basically join the two tables. A joining of the two tables, item and line item, would basically suggest that that item has been sold because that item number would not be a foreign key if it wasn't in fact sold. So I could select distinct item names from the item table where join the line item table on joining the line item table on item.item number is equal to line item.item number. And so what I would want is I would want the distinct item names. And if I do this, I'm going to get the same 12 rows. And so the exists clause is, one way to think about it is a roundabout way of basically getting a true return when there are corresponding rows existing being returned as part of a subquery. We don't really have to use a subquery to get what we want, which is items that have been sold. More specifically, the exists clause is not very useful when we use it by itself. What is more useful is in fact the not exists clause. The not operator is an inverse operator. The not exists clause returns a true if there are no rows returned from the subquery. So let me take the original exists clause that I wrote, copy it and paste it, and instead of calling this an exists, let me try it as a not exists. With the not exists, What I am going to get from this query is item names from the item table where they do not show up in the line item table. Now, that part of it cannot be obtained with a simple join. A join is only possible when primary keys exist as foreign keys. If those primary keys are not existing as foreign keys, you're not going to get those with a join. And so the way to obtain those results or items that have not been sold, you obtain that through a not exists clause. And so if I run this query, I will get 8 rows returned or 8 items. These are 8 items that have not been sold. SQL also allows us to perform set operations. There are two types of set operations that are possible, one of which it does allow and one of which it does not allow. The first set of operation is considered union. Union is a set operation that takes the results of 2 queries and adds them together. By that, I mean the results that are returned by one query are added to the results that are returned by the second query. An example of that is as follows. Again, using the text database, let's select item name and, for instance, what other attributes might item have, item type. Let's say we're selecting a specific item type. Let's say you're selecting the item type C. Now, what we can do is we can take those results that are returned by this query, item name and item type for the item type is C, and so we have 8 rows returned, and we can, with the union clause, have a query below that. Let's say we have another item type called F, that have been sold, for instance. And so what this query will do is it'll take those items that are returned by this first query and add them to those items that are returned by this query where the item type is F. And for item types F, we're looking for those item types that have been sold or that exist in the line item table. If I run this, I get C's and I get F's as well. Unlike the union operator, the intersect operation is not implemented in MySQL, but returns the rows that are common to the results of both queries. These are 2 of the set operations that are supported by MySQL.